Okay, welcome to our lecture on anabolic hormone response to exercise. Now, if you think about it, what's controversial, when you turn on sports TV like ESPN or Sports Center at night? What do we see a lot? Well, you look at the headlines and you see some of the top stories, you're like, whoa, hard to believe. Yeah, it's really hard to believe that an athlete getting paid, $100 million contract might use an ergogenic aid. I grew up in San Francisco Bay Area, and they show pictures of Barry Bonds when he was for the Pirates versus San Francisco. You look at Mark McGwire before and after purported steroid usage. And this is his batting average before and after steroid use, at-bats per home run, and then slugging percentage. You see they're all improving. So this sex hormone explains why men are the way they are. Explains why we fight, right? Why we start wars. Why we are like this at football games. And what is that hormone? It's testosterone, right? So testosterone is what we call an androgenic and anabolic hormone. Now, it's produced from a cholesterol molecule. And that's important. So cholesterol serves as sort of the backbone for testosterone. So let's talk about this. Testosterone is released in the testes in males and adrenal glands in females. And the thing is, again, talking about differences between males and females is that, well, guys have 20 times more testosterone than females. And again, females are in the adrenal glands and guys are in the testes. Now, remember I said there are two properties of testosterone that you want to be sensitive to. The first is that it's androgenic, and the second is that it's anabolic. Now anabolic essentially means that it will increase tissue size of, for example, the skeletal muscle. It'll increase force of skeletal muscle. The androgenic properties refer to its secondary sex characteristics in males, like deepening of voice, body hair, things like that. And also testosterone is a prohormone, and that means that it can convert to another hormone, in particular estrogen. Now, one thing I want to get you to be sensitive to is that anytime you're looking at a substance or a chemical in the body, realize that there's a lot of control mechanisms for that. And testosterone is just one of numerous examples of this. So like many hormones, testosterone's first control point is the hypothalamus. And the hypothalamus releases gonadotrophin-releasing hormone. And that stimulates the pituitary gland to release luteinizing hormone. And luteinizing hormone goes to the gonads, or in this case the testes, specifically in the Leydig cells, and causes them to release testosterone. Now, one of the key points, if you look at this graph, is that testosterone is released. That feeds back onto the hypothalamus. If it gets too high, then it'll shut down the release of gonadotrophin-releasing hormone. Testosterone can also convert to estrogen, and if that gets too high, that can also have negative feedback. So what this does is keep testosterone in a normal range. Except if an athlete or someone were to take testosterone and go into super physiological ranges, then you would see drops. So we see the hypothalamus itself is affected by stress, by emotion, by smell, and even energy balance, right? So obviously if we are dieting hard, you don't want to have necessarily a high amount of anabolism in your body, so testosterone is going to lower. If you're eating a lot more, then you might see testosterone go up. If you're stressed, if you have a lot of negative stress, then testosterone might lower, and emotions will also affect it. So this is a classic study that was done by Basson and colleagues. What Basson did was, if you look over, you have a no exercise condition and an exercise condition. In the no exercise condition, you had a placebo group, and then you had a testosterone group, where they increased testosterone about 5-fold. You see the same thing over in the exercise group. If you look at fat-free mass, which is an indicator of muscle, triceps size, quadriceps size, bench press strength, squatting strength, one thing that you notice is that essentially as if you give testosterone, then you actually get increases in all of those: strength, muscle, tricep size, without even training. Then if you have people who do exercise, we get an additive effect on top of that. So as far that's exogenous evidence, meaning that we gave testosterone. But if we actually look at a concept versus T max and T minimum, we see more support for the training effect of testosterone. So basically what Dr. Bevan and colleagues did is they had 23 elite athletes perform 4 resistance training protocols. And they all used compound movements like bench, squat, rows on 4 separate days. Now all these 23 athletes participated in 4 different workouts. You had a heavy workout, a light workout, a moderately heavy workout, and an explosive workout. So what they found is that the human response to training is in general variable. So roughly a quarter of the people peaked in each condition. So you might respond and have a higher testosterone response to lifting heavy, and for example, I might have a better response by lifting powerful. They then took people and said, okay, which workout caused the maximal testosterone response and which workout caused the minimal? And so the maximal is called T max and the minimum was called T minimum. They then trained for several weeks at their maximal as well as their minimum. So here's what Dr. Bevan found. If you look at the maximal protocol, okay, the black circles represent change in strength, and the gray boxes represent change in muscle. But what you see is that percent increases. You see a 6 to 7% increase in strength, and you see a 9% increase in muscle when they followed the T max protocol. When you look at the T minimum protocol, they got basically no changes in strength, and their muscle tended to go down. So this suggests that the testosterone response, at least from a correlational standpoint, does seem to go with gains in muscle size and strength. So how does testosterone work? Well, testosterone directly diffuses into the muscle cell, and it directly increases transcription of muscle proteins. So it affects protein synthesis transcriptionally. And testosterone also increases what's called insulin-like growth factor 1, or IGF-1, in the muscle, and it blocks or antagonizes the catabolic hormone cortisol from binding to its receptor. So if we look at a training session, how many different variables can you think of when training that you can manipulate? I'll give you an example. For example, you can select the choice of exercise. You have compound versus isolation. How many different other alternatives do you have? Think about that. And then let's blow this up. You have rest period lengths. You have choice of exercise, the sets that you decide, or volume, the order of exercise, the resistance or intensity used, the muscle action, as well as the contraction velocity. So it's a classic study by Häkkinen, and what Häkkinen did out of Jyväskylä, Finland. Now Häkkinen has done more strength training studies than anyone in the history of strength training. And the thing about Häkkinen is I got a chance to visit him on a number of occasions in Finland and just pick his brain. And this is a cool study that he did. Basically, you have protocol A and B, and what you're looking at is testosterone response here on A and B. Training session A, they train at their 1 repetition maximum. And training session B, they train at their 10 repetition maximum. What you notice is that session A has less testosterone release, so they did 20 sets of 1 RM or 10 sets of 10. Notice that the sets of 10 had a greater testosterone release than the 1 RM, so B had greater than A. Now think for a second. One of the things we see stuff, we always want to think mechanistically, why is it happening? Well, what energy system are you using with the 1 RMs? Okay? Now, what energy system are you primarily relying on with the 10 RMs? If you said the ATP-CP system for 1 RMs, you'd be 100% right. And if you said the glycolytic system for the 10 RMs, you'd be right on that too. And so what's produced during that type of high-intensity 10 RM session? A lot of hydrogen ions, right? We can see that response by seeing the blood lactate levels. So what we think is that metabolic stress, in other words, like hydrogen ions themselves, maybe even lactate, seem to trigger this anabolic hormone response. And this will lead us to what's called the metabolic theory of growth. And then we see here, essentially, if you were to look at these individual data points, individuals seem to peak in muscle growth in both type 2 and type 1 fibers at around 70, 75 to 85% intensity, or 8 to 12 repetitions. Now, relative intensity is also important. Basically, Rostad out of Norway, a Norwegian Institute of Sport, he investigated testosterone response to 70% versus 100% of 3 RM front, back squats, and 3 sets of 6 on leg extensions. So basically what it means is like 100% of your 6 RM means you can't do more than 6 reps. Where 70% means if you did 6 reps, you probably could end up doing like 12. So why is this important? Well, you see so many people go to the gym and they don't change. But they're like they do this rep scheme. Oh, well, they're doing like 8 to 12 reps. But the bottom line is they're not pushing themselves within that rep schema. And if you look at the 100% area under the curve, as well as free testosterone levels, you see testosterone response is much greater with the 100% versus the 70%. So what's the bottom line? Don't BS in the gym. If you're going to make gains, you need to go all out. Now, as far as exercise choice is concerned, one thing we know is that greater muscle mass that's activated, the more testosterone response. So here we see Rostad again, that bench press elicited a 7% increase in testosterone versus a squat, which elicited a 15% increase in testosterone. So more muscle mass you activate, the more compound the movement is, the more the testosterone response will be. This is why some people will call compound movements more mass builders versus isolation movements. Now, as far as volume is concerned, volume is typically defined as sets times reps times weight lifted. But we're just going to talk about sets, which modulates it a lot. This is a testosterone response. Notice that 3 sets cause a greater testosterone response than single. So what we will say is that multiple sets result in greater responses than single sets. What about the exercise order? Now, theoretically speaking, if you were to just do arms alone, you get very low hormone response. But if you did arms after legs, you would get a massive hormone response. So this was tested by Rostad, and what Rostad did is they trained legs before arms. Now, I have to emphasize this, okay? Remember exercise order. They trained their legs before they trained their arms. Okay? So if you look at the hormone response from the leg plus arm group, it is much greater for testosterone, for example, if you look at the graph still at left, than training arms alone. And if you look at change in 1RM strength and the legs plus arms compared to the arms, it was much higher for the legs plus arms compared to the arms. Same thing with peak power changes. And this is over several weeks of training. I'm not showing this graph, but they also found greater increases in muscle size and the peak of the biceps compared to the non-group. Now, another study by West in 2009 actually did arms first and then legs after. And so the arms first is a low hormone, or LH, and then, the LH is no legs, and the HH is high hormone, which is legs, then, after arms. So you have the low hormone, no legs, high hormone, legs after arms. Notice there's no differences in cross-sectional area of the arms or strength. What we think is that performing legs after arms may move blood away from the arms, negating positive testosterone effects. So order is important. What about chronic change in testosterone? One thing we know is that athletes who train for power tend to have more testosterone. Now that could be causal, could just be that the sport selects out people who have higher testosterone levels. We're not sure. But endurance athletes have the lowest testosterone, soccer intermediate, sprinters the highest. Well, now one thing is how we talked about acute change in testosterone, but how do we change it chronically? Well, basically what you're looking at is testosterone levels and weightlifting performance. So Hackett actually traced elite Finnish weightlifters over 24 months. That's a hard study. And you look at their weightlifting total, you see that from 0 to 8 months it's plateaued, and then it jumps up. And then it's plateaued again for several months, and then it jumps up. That's the graph on the bottom. The graph on the top is testosterone. Notice the testosterone response parallels the change in strength. Now, why is this happening? Well, we had to think historically about how powerlifters and weightlifters trained back then. They trained by what's known as traditional periodization. In traditional periodization, you followed one program for several months, and then you changed it. So you might go for several months conditioning cycle, then several months strength, and several months power. So basically what you're seeing is every time they change it up, they're getting increase in weightlifting results as well as testosterone results. So what we're basically thinking is that the resting testosterone response changes, or those changes are dictated by change. So we see here a pretty good relationship between change in resting testosterone levels and maximal force as well as maximal power. So if you look, basically, if you do linear training where you never change your workout up, testosterone might rise at the beginning and then it'll drop. But if you change your training up continually, testosterone will constantly adapt. This means that you need to periodize your training. Now, intriguingly enough, testosterone levels also correlate to power. So we see here is that resting testosterone levels are related to change in power output. We also see that testosterone rises after explosive movements, and these changes correlate to greater power output. So when you train acutely, you get acute rise in testosterone, and that seems to actually sort of prime the nervous system to optimize power output. So can we take this into our actual training? The answer is yes. So what you see here is you have a control group which did a normal warm-up, and that's essentially the open squares. I want you to look at the top group, okay? And you have the black, in which they did a sprint, a non-weighted sprint. And basically what you see is that if you look at salivary testosterone levels in the upper left corner, no changes happen with the control group. When they did a sprint, testosterone went up. The question is, does this actually modulate the strength response? Well, if you look here, here's squatting, okay? If you look at the control group, their 1RM was 191 kilograms. But when you actually did the sprint first, the non-weighted sprint first, it went up 5 kilograms, okay, which is about 11 pounds. It went about 11 pounds. Think about that for a second. So basically, how you warm up, if you warm up explosively, that can increase your performance. It also increased power output, as verified by the sprint. So most people, when they warm up, they go through the motions. But once you're warm, if you're ascending sets, you're doing explosively, that can augment your maximal strength sets. So you need to warm up with higher velocities. As far as endurance is concerned, testosterone lowers at high to very high volumes, but not low to moderate volumes. So basically what we see is that runners who are running like 90 plus kilometers a week have low testosterone levels. So if you're worried about testosterone, you'll have to modulate how much you run. Now, why does this occur? Well, think about it. If you look at endurance runners, they have very small frame, very small amount of muscle. One of the reasons why is because the high amount of running causes a calorie deficit. And we think the calorie deficit is sensed by testosterone and lowers testosterone. You can see this here. If you look at a normal day, testosterone levels, it's high. If you fast, testosterone lowers, and when you refeed, it raises. So it's likely that that running is causing a deficit, is causing a lower of testosterone. In fact, there are studies with long-distance runners where they actually show all the signs of being hypogonadal. So the one way you can counter that is either shorter runs or dramatically increasing calories to compensate for calorie expenditure. So with that, we're going to take a break, and our next lecture will be on this hormone right here, growth hormone.